hope you've enjoyed the past 3 days and are ready for just one last talk before we all have to leave Google I/O this year. My name is Kat. I'm a software engineer on the Firebase team.
And I'm Kiana from Firebase Developer Relations.
We, as developers, never have enough time, and we're always looking for new tools to help us build faster. So today, we're going to take apps that we have built on cross-platform frameworks and add Firebase to them to take them to the next level.
So over the past couple of weeks, I've been building this app. I think it's pretty cool. It's a photo scavenger hunt where you have a different category each time, and it gives you a couple options. So for this one, up here on the screen, we have tech gadgets, so maybe we'll get an option between a phone and a laptop to take a picture of. And the neat thing about this is it was actually written on Flutter, which is a cross-platform framework that uses Dart, a modern reactive language, and then it compiles down to native interfaces so you can still get featured on either the iOS or Android app stores.
And since I come from a web background, I've built the same app using React Native. React Native is another cross-platform framework, but instead of writing in Dart, I can use JavaScript, which I'm more comfortable with. There are a lot of different cross-platform apps. You might have heard cross-platform frameworks. You might have heard of Xamarin or Ionic. Today, we're focused on Flutter and React Native. All of these allow you to develop in one code base, but target multiple platforms. And we can choose the one which we're most familiar with the language and the tooling around it. So long as we don't need down to the metal performance, this can save us lots of time if we develop this way. So before we get too much further, let's check out a demo of the app we have built. So this is the Flutter app that Kiana has been building. We have this nice tutorial, which tells us we'll be taking pictures, and along the way, we'll get some trophies. Here's our progress screen. We can see the different levels we've already completed. And let's go ahead and check out the next level. Here, we'll need to upload a picture of a hat. Nice hat. And this goes to the server, verifies it's actually a hat, and tells our app that we can continue. And here we've won our first trophy. Awesome. So let's go back to our slides.
So I think we built a pretty nice app, don't you?
Yeah.
But unfortunately, this is our user base right now. Me, you, and a couple friends from our office. How can we make our user base look like this, with users from all over the world engaged and actively using it? Unfortunately, right now our user base is actually more looking like this. The people who we have gotten to use it don't have a great experience, and they're not even getting to the second level. So how do we increase our user engagement? We've tried adding some ads. I've done some sharing with friends, but what's next?
This is where Firebase can help us. Firebase, like the frameworks we've been building in, is also cross-platform, so it's a good fit. Flutter and React Native allow us to build how our app looks and its functionality, effectively acting as our front-end code, while Firebase provides tools and services that our apps can connect to, giving us the power we would normally get by running our own backend. To do this, we've used integrations that already exist. To integrate Firebase with Flutter, we're using the Flutter Fire plugin, and to integrate it with React Native, we use the React Native Firebase module. This allows us to add all of the features of Firebase, which can help us understand our users, discover issues, and tweak it so that our users will love our app. So let's go back to the issue that Kiana mentioned. We have lots of people giving up, not a whole lot of usage, people are leaving us bad reviews. It's not great. It turns out 50% of all issues that people leave bad reviews for are due to things like the app crashing or hanging due to network issues or heavy resource usage. These are all errors that we as developers can fix and should fix. When I see it in my own app locally, I can debug it easily. But even if I know these issues exist in the wild, sometimes it can be hard to find them because I can't reproduce them locally. Firebase allows us to add observability. Google Analytics for Firebase automatically gives us metrics such as revenue and week-over-week retention, which versions of our app are being used by people. But to gain specific insights, we can add custom analytics. And this allows us to track things like what levels are people reaching? which are the easiest options in our scavenger hunt. With performance monitoring, I'll be able to measure latency. Out the door, we get traces for things like app start and network requests. But we can add custom traces to get fine-grained measurements of latency. With crashlytics, we'll get a report every single time a crash happens in the wild. And this is very useful for finding those issues that people aren't reporting to us. With native apps, we just drop it in, and we'll get the line of code that the crash happened on. With cross-platform apps, we'll have to capture the crashes ourselves, but then we can use the custom logging functionality of crashlytics to log them to the servers. Now, analytics and performance monitoring are both available on Flutter and React Native, while crashlytics is only available on React Native module right now. However, if you like what you see and you're using Flutter, all of these are open source repositories, so feel free to contribute. To streamline our demo, we've already done a little bit of setup. We've created our project, Firehunt, and in our project, we've created apps for each of our iOS and Android versions for React Native and Android. React Native and Flutter. We've then dropped in the modules we'll want to use for Firebase. Here, we're using Firebase Core for analytics, performance for performance monitoring, and crashlytics needs the Fabric and crashlytics CocoaPods. For Android, we would be doing something similar, but using Gradle. And lastly, we've done a little more setup with crashlytics, which you can read the documentation for here. OK, so set up all out of the way, let's jump to our actual demo. What do we get as soon as we've set this up? We'll get an overview with analytics for our apps. But it looks like none of our apps have very many users. The numbers aren't going to be so interesting. So let's go take a sneak peek at Bingo Blast, which is an app that's been out in the wild a little bit longer. Here's our analytics dashboard. And as you can see, we have our daily users in green, our weekly users in purple, and our monthly users in blue. And we can scroll down to get other metrics as well, such as how much revenue the app is making and what versions of the app people are using. And if we scroll down to the bottom, we can see where in the world people are using our app from. So in this case, a lot of people are playing Bingo Blast in the US, but also all around the world. We can also take a look at the Events tab. And this shows us the user events that are tracked in our app. We get a bunch of these for free, such as app installs or app removals and session starts. But this is also where we'll be able to see our custom analytics events, such as when people level up. If we check out our audiences, this is where we can segment our user base and target different Firebase features to different segments later on. Here we've grouped things by purchasers and even purchasers by locality. So we can have features which are targeted specifically to, say, people in Australia. All right, let's actually get a look at what adding a custom analytics event looks like in code. Here, we're using React Native. We'll be doing something similar if we were doing this in Flutter. The first thing we'll need to do is import our Firebase module. And here we have the image picker screen. This is the screen which allows you to pick an image and receives the verification from the server. If we have the right image, it will call complete level. And if we have the wrong image, it will call wrong image. So we want to add a custom analytics event when someone completes the level. Let's go ahead and do that. Here, we've given the name of our analytics event to be level, the number that this level is, reached. And we're calling firebase.analytics.log event in order to actually log that to the server. So let's go ahead and run our app. Skip the tutorial since we know what we're doing. Let's look for a cookie. And we'll use this picture of a cookie that we took before. Submit that to be verified. And it looks like our verification worked, and we want a trophy. Awesome. So now let's take a look in the console. We can see that these custom analytics events are coming through in the debug view. And this will give us a good idea of how our analytics will be coming in as we add them to our app. So here we can see we have a bunch of screen views, a bunch of clicks with user engagement, and finally we can also see that level 3 has in fact been reached. All right, so while we're still in the console, let's take a look at what we get from performance monitoring out the gate. I've added no custom code. The only thing I did was add the CocoaPod to my iOS version or my Gradle dependency in my Android app. And here we can already see the sorts of traces we can get. I've got no major issues, but I do have a minor issue with app start. It's taking almost 600 milliseconds. That's probably a slow enough start that unless I give someone a progress screen, it might turn them off from my app. We can also take a look at the network requests. And from this, we can see that all of our requests, our network requests, are in fact successful. But there's this one here which is taking 2 seconds. That's kind of slow. Let's dig into it. This is the endpoint that verifies our image. And it's probably slow because we have to upload a large image on occasion. It depends on whatever our user provides. So maybe an optimization we can make is making our image smaller or somehow speeding up our machine learning algorithm on the back end. That, however, is a problem for my back end self tomorrow or the day afterwards. OK. So what about crashlytics? That was a good overview of performance monitoring. Let's go back to the code and see how we can add crashlytics to pick up the crashes that are happening. If we go see our app and check out the Trophies tab, we'll see that there's a crash. This was reported to me by Kiana, thankfully, a couple hours ago. And we can use this to see how crashlytics actually works. So again, we're in our trophy screen. The first thing we're going to do is import Firebase. And when we get an error, we'll use the global handler to capture it and log it to crashlytics. Here, we'll grab the stack trace, log that, and record the error. So now if we run it, we'll be able to capture the crashes. Yep, and that's just not working. So let's go to the console and see what that actually produced. We can go into our first issue here. And our stack trace here looks like a whole bunch of native mumbo-jumbo. Not very useful if what I'm actually developing is a React Native app. But we can take a look at the logs. And we can see that this was due to actually, let's go to the previous stack trace. If you hit the arrow, yeah, that one will give us this nice stack trace, which tells us that in our trophy screen, we've typed in render tropes. Looks like a typo to me, so let's go ahead and fix that. All right, we'll just add 2 more letters, run our app again. And now we'll actually be able to see the trophies that we have rightfully earned. So now that we've fixed all of the issues in our app, what else can we do?
So if we go back to the slides, the next step in what we want to do is try to start experimenting with our user base. By adding cloud messaging and remote config into our app, we can start experimenting with different engagement strategies, run tests with subsets of our users, and then we'll be able to see what's working using that analytics we just added. So the first step is with Firebase Cloud Messaging, which is the easiest way to add push notifications into your app. It works across iOS and Android, just like Flutter and React Native. And once it's set up, we can instantly send a push notification to all our users. Plus, if we add a little bit of extra code, we can actually take that notification, put it into our app, and then run some custom code to do an interaction based off of that. We can even target our messages based off things like locale and people's experience with our app. So how does it work? Well, we either have our Firebase console send a notification up to our server, or you can actually run your own API server that does things programmatically. Then once it's at our Cloud Messenger, it'll send a notification out to all our users who have registered notification tokens with Firebase. So let's switch back to the code and see how it works. So here we have our Flutter pubspec.yaml, and we're just going to start out by adding our Firebase messaging plugin. Cool. And then we run packages get, and it gets our new values. Then we're going to go ahead, and this is our main content screen, and we're just going to import our new package. And of course, it hit it, because Dart is pretty awesome. Then in our content state, we're going to just go ahead and create that variable, and then initialize it. So in here, you can see that we request a notification permission, and this is mainly for iOS. It'll pop up a question to our users asking, hey, do you want to enable messaging? And it's just one of those required things that iOS makes you do. But you can also see that we get the token here, and if you save that to your database, you can actually target that specific user for a custom notification later. Then we are going to add some extra configuration code, and this will allow us to handle the notification right in our app. The first two, on launch and on resume, are if our user hits the notification and we're not currently in the app. It'll send that data on to us, and then we'll do things like navigating to the right page. However, if we're already in the app, we want to alert the user of that notification, because the system's not going to handle it automatically. So we go ahead and show the alert and then handle that code. So the final thing we want to do is go over to our Android manifest. And we're going to register a custom intent handler just so we make sure that Flutter sends that notification right to our app. Cool. Let's run that. And while it's running, let's go ahead to our console. And we'll go down to our Cloud Messaging tab. And here we can create a new notification. Let's do something like check out our new levels. And we'll just give it a label and target our Android users for this one. And then we hit send. And then back in our Android app.
Do we want to add advanced options?
Oh, yes. And then we have some extra notification stuff just to handle it inside of our app. So we're going to add some custom fields. The first is just some text for our in-app notification. And then the location we want to go, which is the progress screen. And then our special intent handler for Android. Cool. Now we'll go back and send the app. And go over to our Android. And in the notification center there, we should have an app pop up. Yeah, it stopped running. Sorry. Let's just send that again. Let's just resend that notification.
Sure, we can do that.
And the cool thing is you can actually just duplicate it and send it right again.
Still looks good?
Yeah. Cool, and let's go back to the app.
I can see it right here on the podium.
Cool, and we already clicked it, and it's at the progress screen. Nice. So let's switch back to the slides and talk about remote config real quick. So Firebase Remote Config allows us to try out different features inside of our app. It allows us to tweak our experiences for different users and different user groups and change the UI based on things like a new feature flag. How does it work? Well, you have a hard-coded option in your app right now, and it gives the same experience to everyone, but we want to change that. So with Firebase Remote Config, we stick in a new variable, and it fetches from the server the dynamic value for that, and then it updates your UI accordingly. So let's try that out. So back in our pubspec.yaml, we're just going to add the remote config plugin. And again, packages.get. Then in our content screen, we're going to import that package once again and create a new variable. And then we'll go ahead and initialize. So this time, we're going to do an asynchronous call. And then using the wait keyword, we're just going to wait for that response back to say, hey, yes, we have a remote config set up. And if we do, we'll go ahead and do a configure settings. And this will make sure that we set some default settings. In this case, we're in a debug mode, so we're going to leave the debug flag on, and then we're going to set some sensible defaults that we already have in our app. Next, we're going to fetch the new remote config from the server, and then update the app accordingly. And we call set state here because that's how Dart knows to update the UI. Finally, we're going to replace the get config function, just so our app knows to check remote config first before we use our defaults. Cool, let's run that. And if we go over to our Find screen, we can see we currently have 2 options, but we want to change it to 3 or 4 and make it a little bit easier for our users. So let's go into the remote config dashboard. And we're going to add our first parameter here, which is going to be find number options, and we'll set it up to 4. And then add the parameter. And finally, the last thing is hit publish to send it out to your users. Then in a couple seconds, it'll reach our app, and we'll just restart it to make sure it fetches those new variables. Since in this case, we only wanted to start on startup, because otherwise the experience would change while our users were using the app. And it just takes a moment to load here. Cool. While this is loading, let's go and add another thing in our remote config.
Sure.
So the cool thing is we can actually add parameters specifically for certain versions of our user base and of our app. So if we define a new condition, say, is iOS, then we apply if they're using our iOS app. And we create the condition. Then we can add a specific variable just for those iOS users, say only 3, because our iOS users are going to have a little bit harder time finding those items. And then we publish the changes. And then if we go back to our app, let's see what that find screen looks like. Cool, and it got to 4. Unfortunately, conference Wi-Fi took a little bit of time to get there, but it came through. And you'll notice it didn't switch to 3 because it knows this isn't that iOS app. And without any code changes, we were able to update that value dynamically. So those were all manual tasks, but let's switch back to the slide to learn about some automatic ones. So the smarts. Predictions, A/B testing, and A/B testing for cloud messaging all allow us to add some machine magic to automate those tasks we were just doing. By using Firebase predictions, we take Google's Cloud ML and actually integrate it right into our analytics data. It helps predict actions that our user base will take, like will they churn or will they spend money? Or we can even have it predict a custom analytics event, like are they ever going to reach the 3rd level? Then with A/B testing, we can go ahead and automate our tests and interpret the results automatically. So we can run tests with just a sample of our users, or we can do it just with a certain audience or one of those prediction events. Then we can see if it made an impact on the metrics we care about, and then roll it out to a larger population if it works. So this is what it might look like. So half of our user base might get, can you beat our latest challenge? And the other half get new levels just released. But it'll do that all for us, and we won't have to choose which does which. So let's go back and do a demo of this. Cool, so this is our predictions currently. And you'll see we have a pretty high churn number, because our app, again, wasn't very good before. Now that our bugs are fixed, hopefully that number will go up. But currently it's at 37% are predicted to churn, but that's a high-risk tolerance. At a high-risk tolerance, we're really saying anyone who could possibly churn, we want to make sure to target them. But if we switch it to a lower risk tolerance, we can do like only the users that we're very sure are going to churn, and maybe we're going to try to ring them for all the money we can get, or maybe we'll just help them do the app, use the app a little easier. We can also set up down here a level 3 reached, which is a custom analytics event that we then took and asked Google to predict, and it will just take a couple days to go and do that prediction. Or we can even run an A/B test on these and target just the users who are predicted to churn. So next up, let's do an A/B test. So it takes a little while to load on conference Wi-Fi, but we'll create an experiment for notifications. And let's do something like giving everyone I/O trophies. So we'll do a short message, and then we'll target our iOS users. And let's do like 100%. Because we want every one of our users to get this one, we just want to see which one does better. So we'll hit next and add 3 variants. Finish a level for the first, limited edition trophy for the next, and then a special trophy for the third, and then next. And our goal here will be session start, because we want people to open up our app and start using it, and that's what we're going to try to optimize for. Then we hit next and go ahead and see an overview of what our A/B test will look like, and then we start the experiment. Now, this will take a week or so to run, or 2 weeks if we did the experiment with remote config, but we actually started an experiment a week ago that we can show you guys. This one was with Android. And it looks like variant A won out. So that's pretty cool. And if we look down, we can see what variant A was, and we can see some of the stats on it. We can see the conversion rate was 22%, which is pretty good, and how many people actually did that event. So nice. Let's switch back to the slides. So what are some other ways I can use all these cool features we just started working with?
That's a good question. One way is we can use predictions to find the users that will churn and give them booster packs, target them. Maybe they're having a hard time with the different levels, so we can use booster packs to help them through those harder levels. We can use Firebase features if we want to redesign our app. We can use A/B testing, see if people actually enjoy the new redesign, and it will also tell us if people are experiencing more crashes with the new redesign, in which case we'll just roll it back. But if we do like it, we can roll it all the way to 100%. We can also use Firebase when producing new content. So I'm sure a lot of you have had that experience where you just want your users to download a new app update so that they can get the new content. Well, we can roll the new content into existing app updates, but hide it behind a remote config variable. Then on the day we want to launch the new content, we don't have to wait for people to update their app. We'll just flip our remote config flag and send a push notification to let everyone know that there's new content waiting for them. So we've taken our 2 apps, React Native and Flutter, and added Firebase features to them. This allows us to observe and analyze using Firebase Analytics, crashlytics, and performance monitoring to see what our users are doing and discover issues before they reach everyone. We can make hypotheses as to how we can improve the experience with them using predictions to segment users that might be churning or spending more money. And we can run experiments on them using A/B testing, targeting remote config and messaging. We'll be able to analyze the changes we have made, what users like, and repeat the cycle all over again. Now that we've added Firebase, when people all across the world come to our app, they will have a smooth and enjoyable experience. Firebase can actually go beyond even this and help us develop our next features using products such as Firestore, which have real-time synchronous capabilities, allowing us to build things like team games so that people can work together to finish scavenger hunts, or using cloud storage so that we can make sure uploads are successful even across spotty networks. But this is the last talk here at I/O, so I encourage you all to go to YouTube, check out the other talks that have happened here these past 3 days, and explore the deep dives on there as well. We want to hear from you, so please check out the website and leave us some feedback. Again, thank you for coming to our talk, and I hope you've enjoyed I/O.